Have you ever wondered why the shortest distance between 2 points is a straight line? Or why the sum of the angles in a triangle always adds up to 180 degrees? These are not just random facts, but the foundation of a vast field of study called geometry. Today, let's delve deep into the world of geometry, as envisioned by the father of geometry himself, Euclid. Euclid, a brilliant mathematician from ancient Greece, authored a book over 2,000 years ago that has shaped the way we perceive the space around us. This book, known as The Elements, contains the essence of Euclid's geometry. Euclid's geometry begins with a set of 5 postulates, or assumptions, that we accept as true without proof. The first postulate states that we can draw a straight line between any 2 points. The second postulate expands on this, declaring that we can extend a finite straight line continuously in a straight line. The third postulate introduces the concept of a circle. Euclid asserts that we can draw a circle with any center and radius. The fourth postulate states that all right angles are equal. This might seem obvious, but it's crucial for building the rest of Euclid's geometry. These 4 postulates are relatively straightforward, but the fifth postulate, known as the parallel postulate, has caused mathematicians countless sleepless nights. It says that if a line segment intersects 2 straight lines forming 2 interior angles on the same side that sum to less than 180 degrees, then the 2 lines, if extended indefinitely, will meet on that side. Euclid used these postulates as building blocks to prove more complex geometrical concepts. For example, he proved that the angles in a triangle always add up to 180 degrees, a fact we take for granted today. He also demonstrated that the area of a circle is proportional to the square of its radius, a relationship we now express as pi times the radius squared. Euclid's geometry, as outlined in The Elements, is based on deductive reasoning. He starts with simple, seemingly self-evident postulates and builds upon them to arrive at more complex theorems. This rigorous, logical approach has not only shaped the field of geometry, but also had a profound impact on the whole of mathematics and science. To summarize, Euclid's geometry is based on 5 postulates about lines, angles, and circles. Using these postulates, Euclid proved a host of theorems and established the principles of geometry. His method of deductive reasoning, starting from simple truths and building towards more complex ideas, has had a lasting impact on the way we approach mathematics and science. So the next time you see a circle or a triangle, remember, there's more to it than meets the eye. Behind these simple shapes lie thousands of years of mathematical thought, all starting with a man named Euclid and his 5 postulates.